Hello everyone, this is Dr. Zach. So today we're going to use inverses to find the derivatives of functions and bases other than e. We're also going to practice logarithmic differentiation, which is not only fun to say, but it is fun to compute. All right, let's get started. For today's lesson preview, you needed to actually log both sides of your expression in order to take that exponent and drop it down in front. Once you did that, you were able to use your implicit differentiation in order to find dy dx. So the derivative of the log is 1 over y dy dx, and that's going to be equal to 1 times the natural log of a. Now, of course, the natural log of a is a number. So your dy dx is going to be equal to y log a, and we know that y was actually a to the x. So we now have a new rule that the derivative of a to the x is a to the x multiplied by the natural log of a. For question B, you use logarithmic algebra to rewrite your log base a function. And so the algebra you should use is the log of a is actually the natural log of x divided by the natural log of a. So your derivative dy dx is going to be 1 over the natural log of a, because that's constant, times 1 over x, and then dx, which is 1. So we now know that dy dx is going to be equal to 1 over the natural log of a times 1 over x. So your lesson preview actually sets you up for some new rules. So as you noticed, knowing your log algebra has become very useful in calculus, just as all of your algebra techniques can be used in order to make your derivatives much simpler. From today's lesson preview, we have determined what the derivative of a to the x has become. We also know what the derivative of log base a of x is going to be. So in general, the derivative of a to the u is going to be the natural log of a times a to the u du dx, and similarly, we know the derivative of log base a. So let's apply these with our first two examples. So for our first example, we have the number 3 in front. If we're told to solve this, we probably want to divide first. We have 5 to the x minus 1 equals 86 divided by 3. Next, we'll take the natural log of 5 to the x minus 1 equals the natural log of 86 over 3. We're going to drop the exponent in front, so we have x minus 1 times the natural log of 5 is equal to your natural log 86 over 3. Solving for x gives us x minus 1 is the natural log of 86 over 3 divided by the natural log of 5. And then, of course, we add 1 to both sides. Now, the nice part about your log functions is it can come in various forms, and when you're working on a multiple choice test, you should practice recognizing the different forms that your answers may occur in. All right, so now we're looking for a derivative. What I want you to recognize first is that we have a product rule. So your dy dx is going to be the first times the derivative of the second. So that will be 6 times your negative 2x times negative 2, and then you want to multiply by the natural log of 6. So that was first times the derivative of the second, plus the second, which is 6 to the negative 2x, times the derivative of the first, which is 1. You might factor out your 6 to the negative 2x and be left with negative 2 natural log of 6 multiplied by x plus 1. Example 3 involves some more algebra. So if we take the natural log of both sides of this equation, drop our 365t in front, we now have the natural log of just a bunch of numbers is equal to the natural log of 2, which is also a number. We're solving for t, so we will do division. We have the natural log of 2 divided by 365 times the natural log of 1 plus 0.10 over 365. And you can simplify that using your calculator. For example 4, take a look at this. This is a nasty looking problem. So we're going to let it equal y, and then perhaps use some of the log rules to simplify this. So we will have the natural log of 4 over x squared, square root 1 minus x, divided by the natural log of 5. Then let's do some algebra to split this problem up and rewrite this as the natural log of 4 minus 2 natural log of x minus 1/2 natural log of the quantity 1 minus x. So that algebra is going to make this much simpler when we find dy dx. So the derivative is going to become our 1 over natural log of 5 times, the derivative of the log of 4 is 0. Well, then we'll have negative 2 over x minus 1/2 times 1 over 1 minus x. Using the chain rule, there's another negative 1. And then we can simplify all of those negatives. But as you can see, using log algebra makes these problems much simpler. So example 5, you can see that once again, we have some algebra. We're solving for x. The base is 5, so in my mind, I think that we are raising 5 log 5. That cancels out to become 1. We have the square root of x minus 4 is equal to 5 to the 3.2. Then we're going to square both sides. X minus 4 is equal to 5 to the 6.4. And of course, we add the 4. So 5 to the 6.4 plus 4 is equal to my x value. For example 6, we're going to use logarithmic differentiation. Notice why this one's different. This one has a variable raised to another variable. And for that, we have to do something special. We have to log both sides. And when we log both sides, that drops the exponent in front. We're left with the natural log of x. So the derivative of the natural log of y is 1 over y dy dx equals, and now we have a product rule. First times the derivative of the second plus the second times the derivative of the first, which is 1. Solving for dy dx gives us y times, we have x minus 1 over x plus the natural log of x. Of course, we need to replace the y value. So with logarithmic differentiation, we have x to the x minus 1 times x minus 1 over x plus the natural log of x. Okay, so I'd like you to take some time, do a little bit of practice, use your algebra skills for numbers 27 and 31, write the equation of the tangent line. Let's work on number 67 and 70. Those should be good. And then you have 5 problems to differentiate. All right, best of luck. Give these a nice try. For homework, you have 2 pages to consider, page 362 and 326. So give these questions a try, and I'll see you for next class.